So now we understand the difference between mass and weight. So mass is the quantity of matter that a body contains. Very simple definition. So it is the quantity of matter that an object has. It is a scalar quantity and the SI unit is kg. Are we clear?
Yes, sir.
Very simple definition. Now let us understand what is a weight. So usually students face some confusion when they first try to understand the definition of weight. Now weight is the force with which the earth attracts a body. So what does this mean? What this means is, so for example, I have this book which is lying on the table. Yeah. So this book, usually the students face some confusion in this topic. So we are on Earth, and there is a table and there is a book lying on it. So this book would have a mass. Say this has a mass of 5 kg. Yeah. Now the force with which Earth would be attracting this book would be the weight of this book. Weight of the book. Weight of the book is the force. Is the force with which Earth is attracting it. And Earth is attracting it with the force. The formula of force is mass into acceleration. So mass is 5 kg. And this acceleration with which the with which Earth can with acceleration is the acceleration when Earth can provide to this book if this book leaves the table. Have you understood what I've said?
Yes, sir.
So, for example, if I remove the table, this book will fall with the acceleration of 9.8 meter per second square. Chris, is it making sense?
Yes, sir.
So that is why I'll have to multiply this acceleration that Earth can provide to this book. So the weight of the book, this would be meter per second square. So 8 5 the 40, 9 5 the 45, 49. So the weight of the book would be 49 Newton and the mass would be 5 kg.
Yes,
Chris,
sir.
have we understood?
Yes, sir.
Now let me take this book. Let me take this book to moon. So now I am on moon. Yeah. So at moon, the mass would remain 5 kg, but the acceleration that the book can provide to this book is 1/6. So let us assume this to be approximately 6 6 is 36, approximately 1.6 meter per second square. Now here, the force with which moon would be attracting this. See, this was the force with which Earth was attracting, but moon will attract this with a force which will be equal to 5 kg into acceleration that moon can provide. So which will be 1.6 meter per second square, and this will be 6 5 the 30, 5 on the 5 8 Newton. So if you see mass on the two heavenly bodies is 5 kg 5 kg, but when we are on Earth the weight of the book is 49 Newton, and when we are on moon the weight becomes 8.
8 meter.
Is it making sense?
Yes, sir.
So now you can go to a planet like Jupiter where the acceleration that Jupiter can provide would be say 7 or 8 times what Earth can provide, and there the weight would be far more. Have you understood what I'm saying?
Yes, sir.
So this is with the a very simple example and calculation that we try to understand the comparison between mass and weight. So in tabular form, if you want the difference between mass and weight, these are the points. Usually they'll ask you 1 or 2 points. So whatever you are comfortable with, scalar quantity, vector quantity, you can tell the units, kg and Newton. This is a very a nice way of giving a difference that mass is measured with the help of physical beam balance. So you would have seen a balance like this. This is how we compare the. This is we
Weight,
yeah balance.
mass.
Yeah, this is how we cover the mass. But a spring balance is looks something like this.
Yes.
So this spring balance, this measures the weight. And one very simple difference is that mass doesn't change, but weight will differ depending upon the value of g, what is the acceleration which is being provided by that heavenly body. And on Earth also, see, what you need to remember is on Earth also, at various points, the g differs. Have you understood what I said?
Yes, sir.
So your weight on Earth will also differ. Your weight will be differ from equator to pole. It will differ on the top of a mountain also. So it depends upon the value of g. Are we clear till here?
Yes, sir.
So again, for mass and weight, I'll send you a few basic numericals. Just go through the numericals. Very simple examples. Approximate weight, magnitude, weight. So these are the simple numericals that you can do so that you understand the concept well. Are we clear, Chris?
Yes, sir. Yes.